Examples in calculus, the product rule. This is video 2. Example 1 uses the product rule in the form y-x equals gx times f-x plus fx times g-x. The following list of 7 short videos shows all videos, including this one, that involve the product rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. The product rule. This rule finds the derivative of a function that is the product of two separate functions. If a function y is defined as y equals fx times gx, then y is the product of two separate functions on the right-hand side of the equation, where fx is the first function and gx is the second function. Since y is the product of two separate functions, y-x, the derivative of y, must be found using the product rule. The form of the product rule used in this example is y-x equals gx times f-x plus fx times g-x. There are 4 separate functions on the right-hand side of the above equation: gx, f-x, fx, and g-x, where f-x is the derivative of fx and g-x is the derivative of gx. Procedure. To obtain the derivative of a function that is the product of two separate functions, complete the following 4 steps. Step 1. Identify fx and gx on the right-hand side of the function you want to differentiate. Step 2. Find f-x from fx and g-x from gx. Step 3. Substitute gx, f-x, fx and g-x into the right-hand side of the product rule to find y-x. Step 4. It is usually necessary to simplify the right-hand side of y-x, and if y-x can be simplified, then it should be simplified. Note that simplifying can involve expanding, collecting like terms, factoring, or all 3. An example using the product rule. find the derivative of the function y equals 2x squared times e to the x. Solution. Finding the derivative. Step 1. Identify f(x) and g(x). Comparing the right-hand side of the equation y equals 2x squared times e to the x with the right-hand side of the equation y equals f(x) times g(x) gives f(x) equal to 2x squared and g(x) equal to e to the x. Step 2. Find f(x) and g(x). Using the power rule, f(x) equals 4x, and from a table of derivatives, g(x) equals e to the x. Step 3. Substitute gx, f(x), fx and g(x) into the product rule. From the previous screen, the product rule is as follows: y(x) equals gx times f(x) plus fx times g(x). So for this example, y(x) equals gx, which is e to the x, times f(x), which is 4x, plus fx, which is 2x squared, times g(x), which is e to the x. Simplifying the derivative. Step 4. If the derivative can be simplified, then it should be simplified. From the last line of the previous screen, y(x) equals e to the x times 4x plus 2x squared times e to the x equals, move the 4x in front of the e to the x. 4x e to the x plus 2x squared e to the x equals, separate out 2x e to the x from each term. 2x e to the x times 2 plus 2x e to the x times x equals 2x e to the x into 2 plus x after factoring out 2x e to the x. So after substituting x plus 2 for 2 plus x, y(x) equals 2x e to the x into x plus 2. See the reminder on the next screen for the reason the polynomial 2 plus x should be replaced by x plus 2. Final statement. The derivative of the function y equals 2x squared e to the x is y(x) equals 2x e to the x into x plus 2. When solving questions from your textbook similar to the example in this video, you should have the previous screen displayed so you can use it as a template to find the derivative, and this screen displayed so you can use it as a template to simplify the derivative. You should then find this topic simple and beautiful. Cheers. Do not forget to check your answers with the answers in the back of the textbook. Reminder. Order of the terms in a polynomial. In a polynomial, the convention is to arrange the exponents of x in descending order from left to right, where descending order means from highest exponent to lowest exponent. For this example, first note that x to the naught equals 1 and x to the 1 equals x. Since 2 plus x equals 2 times 1 plus x equals 2 x to the naught plus x to the 1, replacing 1 with x to the naught because x to the naught equals 1, and replacing x with x to the 1 because x to the 1 equals x, equals x to the 1 plus 2x to the naught because exponent 1 is higher than exponent naught, equals x plus 2, replacing x to the 1 with x because x to the 1 equals x, and replacing 2x to the naught with 2 because x to the naught equals 1. So 2 plus x should be replaced by x plus 2 because now the exponents of x descend from left to right. Reminder. Checking that the simplifying is correct. One of the many advantages of maths is that your working and answers can frequently be checked. In this case, the derivative in the second line of step 4 before simplifying was found to be y dash x equals 4x e to the x plus 2x squared e to the x. And after simplifying, the final answer was y dash x equals 2x e to the x into x plus 2. These equations are identical because 2x e to the x times x equals 2x squared e to the x, and 2x e to the x times 2 equals 4x e to the x. So the simplified answer in the final statement in step 4 is correct.